Alrighty guys, so what we're going to do today in this video is go over the functional groups that we learned about. That way you guys have a refresher before we finish up the assignments for the rest of the semester. Alright, so the first functional group that we talked about were amines, and amines are very simple. It's basically a nitrogen that is bonded to an R. Now if you guys remember, an R just represents a carbon chain, or even if it's just one carbon by itself, as long as you have a carbon somewhere here, that's going to be universally represented by R. So if you have something like this, this would be the R portion, and then we have the NH2. This portion would be the amine. Okay, so you could have NH2 and this would be an amine, or you can have something like this where you have NH and then the chain continues. This would also be an amine. You can also have just an N in the middle of some kind of chain like that. Maybe it forms like some kind of ring. Regardless of what it looks like, as long as you have a nitrogen in the midst of a bunch of carbons, you're going to have an amine. Alright, moving on. We're going to have an alcohol group. Now, alcohol groups are very easy to identify. If you see an OH bonded to a carbon chain, that's going to be an alcohol. So it's usually going to be at the end of a chain, so it's going to look something like that. Now, just a heads up, sometimes it will be drawn like this, where you have a carbon chain, and you have an O with a single bond to an H. This is basically the same thing as this. The top way is, I guess, the faster way to do it without drawing that single bond, but regardless, both of these are going to be alcohol groups. Alright, moving on. The next one that we talked about are ethers. Ethers are very simple. You have a carbon, you just have an O, an oxygen, in the middle of a carbon chain. So it might look something like this, where it continues. Sometimes it'll be like a closed structure, so this would also be an ether. So this part would be the ether, and this part would be the ether. It's just an oxygen in the middle of a carbon chain. Next, we have carbon rings. Now, carbon rings are any closed structure that are made of only carbon. So you could even have a triangle. This would be a carbon ring. You could have a square. You could have a hexagon, which is probably what you'll see most of the time. Doesn't really matter. That's going to be a carbon ring. You can even have things coming out of it, but this part right here is going to be a carbon ring. Just a heads up though, something like this in the previous example is not a carbon ring, and the reason why is because even though it is a closed shape, one of the corners is oxygen. You see how these corners are all carbons, but one of the corners is oxygen, and that means that this is not a carbon ring. Carbon ring has to be made of only carbons in that closed shape. Alright. Next, we have carboxylic acids. Now, carboxylic acids are very similar, or one of the parts is very similar to an alcohol. If you notice, there's an OH here, but the OH is connected to a carbon, which is double bonded to an oxygen. If you see this, it's going to be a carboxylic acid. So an alcohol will look something like this, where it's just OH, right? This would be an alcohol. But if you have an OH that is connected to a carbon that is directly double bonded to an O, that is going to be a carboxylic acid. Okay, now the thing that you have to be careful about this is that the OH has to be directly connected to the carbon that's double bonded to the oxygen. If you have something like this, for example, this would not be a carboxylic acid. This is not a carboxylic acid, and it's because if you notice the OH, the alcohol group, is connected to a carbon, but the carbon is not double bonded to an oxygen. It's one time removed, so this is just going to be a regular alcohol, but here if you notice, it's directly connected to a carbon that's double bonded with O, and that would be the carboxylic acid. So just make sure you guys are careful about that. The next one is an ester. Esters are very similar to ethers. You're going to notice that there's going to be a carbon chain, and in the middle of it, there's going to be an O. Now, what makes an ester different from an ether is that the oxygen is directly connected to a carbon that's double bonded to an O. So this part right here would make it an ester, whereas an ether would look something like this, where there is no carbon directly double bonded to an O attached to that O. Okay, just a heads up that if you have something like this, where you have an oxygen connected to a carbon double bond with an oxygen right here, this would be one ester, but you're going to notice on the other side there's another carbon double bonded with an oxygen. This is going to be another ester, so that would be two esters. So just make sure you're careful about that. As long as you have the oxygen directly connected to a carbon that's double bonded with an oxygen, that is going to be an ester. So just make sure you're aware of that. All right, going forward, we have some functional groups that are a little bit similar. We have aldehydes. Now, aldehydes are going to be at the end of chains. Okay, they're going to be at the end of carbon chains, because the end of the chain, you're going to have a carbon double bonded with an oxygen bonded to a hydrogen. So you could draw an aldehyde like this, or it might just look like this. Okay, because remember, we ignore hydrogens that are directly connected to carbons, and so you could even just skip drawing the hydrogen, and that is going to be an aldehyde. Again, they're usually at the end of carbon chains, and it's going to be a carbon double bonded to an oxygen connected to one hydrogen. A ketone is a carbon double bonded to an oxygen that's in the middle of a carbon chain. So if you have something like this part right here would be your ketone. Ketones can also form these ring structures. They could have closed shapes like that. This would also be a ketone right here. So if you see a carbon double bonded with an oxygen, not connected to something special, just in the middle of a carbon chain, that is going to be a ketone. All right, almost done. Okay, we have two more, and the next one are amides. Now, amides are similar to amines, but the nitrogen is connected to a carbon directly double bonded with an oxygen. So you might have something like this. You have a nitrogen with two hydrogens connected to a carbon that's double bonded with the oxygen, or sometimes the nitrogen might even continue the carbon chain. So you might have like NH and it might keep going, or you might have a situation where the carbon is connected to a nitrogen and the nitrogen goes off in two different directions afterwards. It doesn't really matter. As long as you have a nitrogen that's connected to a carbon that's double bonded to an oxygen, you're going to have an amide. I do want to make sure you guys know, though, that if you have, just like the carboxylic acids or even esters, if the nitrogen is removed one time, like this, if you notice the carbon that it's directly connected to does not have a double bond to an oxygen, right? It's 2 times removed. If it's 2 times removed, this is not an amide. Okay, this is going to be an amine, because the carbon that it's directly connected to, this one right here, is not double bonded with an oxygen. It's 2 times removed. So if it's 2 times removed, you're not going to have an amide, you're going to have an amine. And then lastly, we have alkyl halides. Alkyl halides are carbon chains with the end of the carbon chain being an X, which symbolizes halogens. Now, halogens are going to be the elements fluorine, chlorine, bromine, or iodine. And when you look on the periodic table, if you go all the way to the right, you're going to have the second to last column. This is going to be the halogens. Okay, and you guys can double check if you want to, but they're going to be fluorine, chlorine, bromine, and iodine. Okay, so if you have the periodic table like this, I know this is kind of a rough sketch, but the ones on the second last column are going to be the halogens. You're going to have fluorine, you're going to have chlorine, you're going to have bromine, and you're going to have iodine. Those are the halogens. If you see those connected to a carbon, that's going to be an alkyl halide. All right, so that was a very quick refresher of the functional groups that we learned about. Make sure you guys double check with the chart that is uploaded as well, just to make sure you have a reference for the functional group, because we will be continuing to study them and identify them in different molecules. We'll see you next time.